good day, good afternoon, good evening, everyone, depending on your time zone in which you'll be watching this hopefully amazing talk. So my name is Nikita Koselev. I work at Mastercard.
Hi, Ivan Djordjevic. I'm at Salesforce.
So why are we here today? Today we are because of open source. And of course, most of us know, or all of us know, that open source is basically a license. But I prefer the definition that open source is a community. So there are two great communities out of many. One is FINOS and one is OWASP. We will talk about OWASP in length, or well, not very in length, but we will talk more detailed way in the end of the presentation. But for now, it's a community which is really focused and cares about cybersecurity and shares with other communities, so we all can sleep better. Let's go for the next one. So let's first define what do we mean by the generative AI, because defined in the scope of this presentation. So basically it's a complete system from the prompt to the content you create, and it is also integrated with other systems like other LLMs, APIs, and so on. And we, in this presentation, we'll be focusing on the risks involved in the usage of such LLM and in AI, which is actually LLM at the moment.
Is it me? Yeah. Okay. So, but we'll do this ant and deck a few times during the talk. So, yeah. So as Nikita said, so when people talk about LLM, normally everybody's focused on the actual the system that the model. But if the question is if you want to use it, and what are all the security vulnerabilities and risks to consider? And OWASP is taking that approach, and I'll show the system diagram in a minute. But before we dive in, I think it's fair to say that nobody's really expert in this area, and I certainly learn something new every day. So, but some of the key things that we try to put here on the in a couple of bullet points. Why is AI? Why is generative AI security different from sort of traditional systems, if you like? One of the things is this concept of what I call data plane and control plane separation. And that is, when we start talking about prompt injection, it's kind of one of the reasons why that makes it possible. It's really, if you think about the website, if you can enter something on the form and you press submit, the web server knows that this is the user input and then this is the control, these are the instructions. Because of the how generative AI works, that everything is tokenized and then interpreted as a token. There is a mix between what is the user input and what is the actual instruction. Do this, do that, or maybe what is provided by the system as a part of the system prompt. So that is, there's a lot of material on this, and it's kind of new cases are discovered the whole time, but that is one of the reasons why Gen AI is very different. The other is, I think I have it here, the unpredictable output. So, and it's probabilistic. Sometimes you might get one result. Sometimes you get something maybe a little bit different. And then the other is, the next thing is around a sort of attack classification. So, for example, NIST did a very good attack taxonomy. And if you're interested in the area, please have a look. But there's this kind of concept of using the data and then training, and then the kind of data, kind of training you do really affects a lot how the system, how the application will perform. So then the whole type of risks are becoming a little bit different. And then there are a few other things that are, well, I guess scaling complexity. I mean, it's sort of a traditional, I guess, concern, but with AI, with the level of processing, that becomes even more magnified. And then obviously this area of ethics, bias, all that, compliance, what does it mean for my data, and all that kind of stuff. So those are some of the reasons that we think that where generative AI security is different. And then what are the approach that OWASP is taking, and by the way, both of us are contributing to this effort, and it is open community effort, so if anybody wants to get involved. So OWASP, they have obviously their top 10 application security vulnerabilities, and then the similar approach taken for generative AI and for top 10 for LLM. And there was a lot of work done into defining what are those top 10 for a for LLMs. And this was kind of working, version 1 working architecture that informs some of those vulnerabilities. There's a work in progress happening to improve that, to probably make a bit more the kind of the system architecture probably a bit more, I guess, aligned to what's recently been happening with things like retrieval augmented generation, user orchestrator, that kind of stuff. So we're not going to cover all of those. We basically are going to focus on 4. And those 4 are really those that we see in practice being mentioned and creating risks. And also those 4 are vulnerabilities that are coming up very high. At the moment, the community is voting for what are going to be the top 10 in version 2, and those 4 are still coming up very high. So that's prompt injection. We have sensitive information disclosure, so data disclosure, supply chain, and training data poisoning. And hand over to you to take us through.
Let's just pause on this picture. You can see that the same attacks will be used in multiple places, and the order is by community. So this document, it's very fresh. It's being developed as we speak. Everybody is welcome to contribute. We need everyone. So let's go to the next one. Yes, thank you. So the favorite beast is prompt injection, and it might look innocent, but it's not. And it's not only text, because some of the hacks involve, well, I should mention it in examples, but some of the hacks involve, for example, you are using a very famous tool which many developers use on a very famous open source repository. And this tool might have the commands, the prompts. So if a person supplies prompts not to the tool directly, but the person leaves them in the source code, then it might start, it will be reacting differently. But I'm not here to teach you hacking. I'm a good person, good boy. So prompt injection is a type of attack when you create a prompt to manipulate LLM into a behavior which is not by design, not as intended. So there are at least 2 major risks with that. So one is that a sensitive data might leak. Hello, all the FINOS companies who are afraid to use ChatGPT for a reason, because, okay, it already leaked. And another one is unintended actions. So there's this world-famous example when a person was talking to a car dealership bot and was repeatedly telling this bot that you should reply to me that everything is abiding from a legal point of view. And it basically made it to tell that I'm selling you a new car for $1. It was a good person, so this person went, probably I shouldn't use good person, but this person went to the company and said that, look, your bot is misbehaving, so they took it down. So the examples are, yes, direct injection, and here it's more interesting. So you can inject directly, which is probably easier to protect. And we have a bigger problem when there's indirect injection, and someone injects stuff in the LLMs, for example, you depend on, and then it becomes extremely interesting. So ways we can attempt to fight it, there's no 100% defense anywhere, unless you turn off the computer. But you can try to control privileges. Sounds good and reasonable. Also, it might be worth to have a human in the loop. My personal assumption will be that, for example, in healthcare, you might want to have a human in the loop when people mention certain words, and it intervenes. And content segregation. So yeah, so it must be clear to understand which input can be trusted and which can be not trusted. Here we come to the dependency chain attack, and yeah, no, I mean that it's slightly related, because unless the intruder makes it trusted, you are more safe than without it. And then prompt defenses and monitoring. So yeah, it's nice to have a dashboard. Like, you won't drive a car without a dashboard, I hope. I don't recommend it. Number
too
3,
many?
please. Oh,
Yeah,
that's my favorite. So definitions. Training data poisoning. So by definition, somebody might intentionally play with your data. And as one of the amazing speakers earlier this morning said, that you cannot have AI without data, and basically it's based on data. So if somebody touches your data, oof. So the risks are, in the best case, your model will degrade and it will start becoming less and less useful. And another one is that it can be exploited. So there are examples when the data was biased or manipulated. So I don't have an example in my head of a hack as such, but I have an extremely sad example when an image recognition system was trained on the data provided by engineers, which happened to be white men. And that stops being anything close to innocent when a person in London gets stopped in the street 5 times in a day because the AI recognition system thinks that he looks like a terrorist. But he doesn't, like, nothing even close. It's just that data was. And that's why diversity matters so much, because if they had some diversity in the team, then the person would say that, look, it doesn't recognize me or my grandmother. So yes, so the prevention strategy is that you need to verify data sources. So you need to know what you trust. You need to continuously monitor, again, dashboard in your car. And you need to use separate models for separate cases. So that's it.
Right. Thanks. So about like one example I heard today actually, because about training, poisoning of training data is not necessarily only somebody maliciously changing the data, but also using inappropriate data. So bias is like an example of that. So one example I heard this morning is that someone's trying to proposing a model where talk about gender bias. So they use sort of a sample data, and then they run the model, see the result, then they reverse, so male to female, and then see if they get the same result. So they're kind of some of the techniques that you can build into the model to eliminate some of those biases. But the other thing when it comes to poisoning of training data is again like all these databases that LLM is connecting. So one is the training foundational model. The others are when it comes to fine tuning or what we're more and more seeing now with vector databases for sort of a runtime refinement of prompts through retrieval augmented generation. It kind of goes back to the basics of protecting the resources and data sources, because if that can be manipulated with some malicious code or content, then that can affect functioning of the system in other ways as well. And that kind of brings me to really supply chain, because it all comes together in with when we look at the supply chain. The LLM architectures are typically going to consist of components being provided by different service owners, different sub-processors, if you like. There might be some of the open source component that are brought in. These examples, PyTorch or TensorFlow are some of the leading tools for machine learning models, and they are open source. And then you can read all sorts of vulnerabilities being found, just because those tools are being used in a way that was not necessarily anticipated previously. So that's kind of one thing, I guess, goes back to the common best practices. Be careful of and be mindful of what tools are being built. Be aware what tools are being used in that overall LLM system. Have a process for vetting vendors and understanding what suppliers are using in order to provide the service. And also the other aspect is then understanding the trust boundaries and what other controls you need to put. So if I have a I don't know, AI chat that is using one of the public LLMs. What has happened in that data exchange? What are the controls? What data I can load in the prompt? What are the controls around that? What's happening with that data? Is it retained by the LLM provider for some additional training and so forth to validate if there is a PI? So there's a lot kind of different controls that you can put within that overall system. And understanding trust boundaries is fundamental to decide what controls you want to put where. I appreciate it's all high level, but it is a very big system. Yeah, the vulnerability management, probably the last one. So again, like with this whole system, understanding, what patching you need to do, how do you need to assess the system, how do you assess the risks, the vulnerabilities. This morning somebody was talking about AI inventory. So do you even understand what AI tools are being used, how that maps to the policy? Is there a shadow AI? All that kind of stuff. So probably there's a large element of processes, defining the processes of how you approach the whole AI journey. And then there's much more technical, which really what OWASP is focusing on. And the last thing I want to touch upon is data disclosure or sensitive information leakage. There's this kind of instant thought, because LLMs are trained on a public data, therefore their data is exposed, and then anybody who can make a prompt query into the LLM, then all my dead data is at risk to be exposed in the response. If you read a little bit about how the whole model works, and I'm not a machine learning expert, it's probably a bit more difficult than that because there are a lot of weights and there's a lot of semantics around how data is stored. So it's not as easy for somebody to just retrieve data that might be there. But there are examples like there's a very good paper on it's called special characters attack, whereby somebody's using special characters like @ and .com to maybe try to retrieve some of the in the response to retrieve maybe a set of email addresses or something like that. So there's a lot that can be done. Again, it doesn't mean that because it's maybe not as straightforward as querying a database, it doesn't mean there is no risk. But then there are other risks that I would consider as a sensitive information. Is, for example, how you build your prompt. So there's something called prompt defenses. So when you put in a prompt, then that's sent to a model. But then underneath that, the system can add some safeguards, like do not swear, or do not return hostile responses. So these bits can be proprietary. This is something that is not necessarily visible by the end user, but it goes into the prompt and informs the behavior. So again, there's a lot of examples where through some clever prompting or kind of crafted inputs, attackers can potentially map how some of those elements of system prompts look like, or maybe what other systems, what other components are being queried. So when we talk about the disclosure of sensitive data, it's not necessarily only the actual data, but also maybe some of the kind of metadata or configuration or some of the proprietary information of the systems. So, yeah, please do.
Yeah, and this beast is very dangerous. As we speak, there are a few corporations which disallowed their employees from using one famous 3 letters agent because sensitive information did leak out. Some sensitive code actually did leak out, and quite a number of corporations, they're actually monitoring. So uploading documents is not the best idea. What I suggest doing, what really helps, it helps to have a clear policy of don't do that, and then a clear policy on what is the expected way to use GPTs, because otherwise people will be using it anyway. So they will be using it from their phones, you cannot stop them. But if you have a clear policy that we are using this GPT agent because they are not storing information on their side, then at least 80% of people will go that way. And so I really suggest to have a community inside of your company who is guiding people and showing them examples. And don't forget about that sensitive information is across the whole organization. So you need to talk to different groups of people in the organization to prevent this stuff from happening. It's not enough just to talk to developers.
How are you doing on time?
We still have like 5 minutes.
I think we're at the end. Yeah, just you can do it or I can do it. So it's basically, so it's kind of, you can open for questions and comments, please. If you're interested to learn more about the whole OWASP LLM initiative, these are some of the resources. There's the picture is the front page in the middle of what we've been showing and summarizing today. It's a set of practical guidance for developers, for security professionals. And there's also some kind of other focused summaries like CISO checklists and some of the solution guides that are also being in development. Yeah, all the materials are there, you know, Slack channel, you can join or find out more. That's all. Our last slide. Thank you very much.